All right, so welcome everyone to this edition of the Roman Community Forum, talking about the Roman town halls, about our the Roman course surveys. So today we have Jessie Christiansen from Caltech Nexi, and today they'll be talking about the Galactic Bulge time domain survey and giving updates on that. So Jessie, thanks again for calling in and giving today's talk, and please take it away.
Great, thanks, Rob. Hi, folks. It's my pleasure to be here on behalf of the Galactic Bulge Time Domain Survey Definition Committee. My co-chair, Dan Huber, gave last week's town hall, and I'm giving this week's town hall. Now, I know that the project office is trying very hard to make sure that the community is kept up to date on all of the goings on and given opportunities for input. Please let us know with this survey. It's important for us to know if we're getting the right people and doing the right things and giving you all the opportunities you need. So if you can, fill out that survey. That would be great. I'll put up a link at the end as well. Okay. So the Galactic Bulge Time Domain Survey is one of 4 core community surveys that the Roman Telescope will undertake. It's this one, you are here. And this is one we'll be talking about today. So just to situate it, here's the sky projected here. This is the Galactic Bulge right in the middle. That's where we're going to be staring for a while, and I'll tell you why and the things we're thinking about. There's also a Galactic Plane survey, which was newly added. Doesn't have any updates for you yet because it's a pretty new committee, but they're off and running. The High Latitude Wide Area Survey is the one that you'll hear about tomorrow if you come to tomorrow's town hall, and also you had a chance last week, so there's already a recorded one. And finally, the High Latitude Time Domain Survey. You should have therefore heard 2 of those and have 2 recorded. So these are the 4 surveys. You have lots of opportunities to hear about them and to have input on them. Okay, so they have broad science goals, each of the surveys, but each of the surveys will also do a lot of science. And part of this work to define those surveys is to maximize the type of science that can be done with them, right? Like, we don't want to set up a survey that does this one tiny, very specific thing and can't be used for anything else, because, Roman is a flagship mission that will be the premier survey infrared telescope in space for a long time. We want to be able to maximize what we're doing with it. These surveys So general astrophysics surveys, yes. So these surveys, this core community surveys will take up no more than 75% of the time. And there will be at least 25% of time available for folks to to propose to, which is also very cool. You'll get to use Roman to do what you want. But one of the ways you can influence what Roman does is through these core community surveys. They're set up for you guys to do the best science for you. So if you have something you care about, now is your time. Okay. So the specific survey we're talking about today, again, the Galactic Bulge Time Domain Survey. This is the definition committee. There's a broad institutional representation, scientific background representation. So myself and Dan are the co-chairs, and you'll see lots of these folks actually I see on the call. So thanks, committee, for dialing in. And we have liaisons with the other committees as well. Okay. So the specific Roman requirement that the Galactic Bulge Time Domain Survey is tasked with making sure succeeds is the statistical census of exoplanet systems in the galaxy. So this is a plot. So if Radek has called in, thank you, Radek, for the update for this plot. This is a plot showing exoplanets that have been found to date, in 2019. Their separation from the host star is on the x-axis and their mass is on the y-axis, and Earth masses. So 1 Earth mass, 1 AU, this is the Earth. So all of these red and black points are previously known planets. The red is Kepler, and we can see that Kepler did a spectacular job of filling out small planets out to about the habitable zone, but wasn't quite able to get to Earth. The goal of Roman is to be able to do a microlensing survey. It will also do many, many transiting planets, but the microlensing survey will hopefully get us down to sensitivity to Earth. But we have to set it up the right way. This survey came with a bunch of requirements. I'm not going to read them all out. You can go find them if you want. But suffice to say, there are precisions we need to get to in terms of exoplanet frequencies to meet these requirements. So when our committee is defining the Galactic Bulge Time Domain Survey, our goal is to make sure these science requirements can be met with whatever survey we come up with. So everything I'm going to tell you about other potential science that we will want to do with the surveys, modifications in terms of cadence or field placement, all of those are predicated on meeting these science requirements. We do these first, and then we see what other science we can do. So that's just to make sure no one is like, oh no, they're going to put in a galactic center field. We won't be able to do the mission requirements. We will do the simulations to show that we can do the mission requirements and then do cool extra science. Okay, so here's an example. Oh, I didn't replace this figure, but I replaced the previous figure. Here's an example showing from Matt Penny's 2019 survey, what a potential field placement might be, 7 fields near the galactic center, which is at 0, 0. Obviously, you want to stay away from a bunch of this dust because you want to be able to see through as much as you can. So here's the ideal 7 field placement from that survey from 5 years ago. There were 6 seasons of 72 days observing the bulge. So for folks who haven't thought about the galactic bulge as much as we have now at this point after a year of working on this, 72 days is the maximum you can actually look at the galactic bulge with Roman, given the L2 orbit and given the sun avoidance and everything. 72 days is the max. We have 2 chances per year. We have a spring field and a fall field to observe the galactic bulge. So we get 2 shots per year, which is 10 seasons over 5 years. But the survey is only going to use 6 of those seasons. So the Penny survey had 7 fields, so a total square degree area of 2 degrees. Each of the fields would be observed at a 15-minute cadence. So every 15 minutes, you come back to this field. Rob said you could see my mouse as a pointer. So we're going to go around these fields and come back every 15 minutes. And then once every 12 hours, throw in another filter. So one of the problems we'll have with the microlensing is distinguishing source and lens flux over the mission. So occasionally having another filter is great for many reasons, including that. Okay, so the sorts of changes that are on the table include the length of the observing season, how many fields we throw down. We could have 7, or we could have 4, or we could have 9. The cadence that we hit those at. Now, hopefully you'll see that those are kind of a direct trade with each other. The more fields you have, the longer it will take to get back to them unless you start sacrificing with exposure. So that's a trade, right? So you can have short cadence on a small number of fields or long cadence on a larger number of fields. But that's the trade. And then how often we do the filter. So these are some of the survey trades being looked at and simulated right now, which, again, the goal is to make sure we can meet the science requirements. There are a few other things that I'll talk through. So in terms of other science to do, besides meeting those science requirements, the project office has given multiple opportunities for people to provide input. There was a white paper call, which was a full-fledged white paper. And prior to that, there was a science pitch call, which was more of a short, just throw ideas at us and see what sticks. And we got 23 white papers and 43 science pitches. When this committee formed and started looking through them, we realized that these calls were last year and sometimes early last year, and numbers might have changed and ideas might have changed and thoughts might have changed. So we actually had a follow-up call earlier this year to these white paper authors to say, hey, something stopped sharing. Let me share again. Okay. Okay, sorry, it vanished. Actually, I think maybe my Chrome crashed. All right, I'll keep talking while I get my Chrome to come back up. There we go. Okay, let me share again.
Jessie, while we have a quick moment, could I just ask a question? All right, so there's good evidence now that free-floating planets may be dominant by number for planets in the galaxy. It's a really important target, and we didn't know about it well when we were forming the idea of Roman Space Telescope.
Mm-hmm.
But it seems to me that the survey might be optimized to allow us to get more masses of free-floating planets. So like that idea of like, okay, we'll do the survey in a way that we can get these other observatories to give us parallaxes.
Yeah, so
or somehow optimize that, because it's a new family of objects, but there might be things we could do to our survey for Roman to optimize.
Yeah.
Anyway.
So one of the science requirements, if you can see my mouse here, 204, Roman Space Telescope shall be capable of measuring the frequency of free-floating planetary mass objects in the galaxy from Mars to 10 Jupiter masses. If there's a 1 Earth mass free-floating planet per star, Roman should be able to measure this frequency to better than 25%.
Yes.
So it is part of the survey that we do this. I think I'll get to this slide in a bit, but the survey pressure for free-floating planets is to go to a shorter cadence, to go to faster cadences,
Right.
to better sample these short events. So that's the survey pressure that free-floating planets apply is moving to a shorter cadence, which means a smaller number of fields, right? And then there is other science, like most of these first three, that want you to go to more fields to get more events. So that's why we're doing these trades.
Okay. Thanks so much, Jessie. I just want to make sure that we were thinking about it.
Yeah, for sure. Thank you. Yes, so we gave an opportunity for white paper authors to provide any updates to their thoughts. You can kind of see a breakdown here of the sorts of topics that were involved. The science pitches had a lot of stellar physics, which is great. So there's been lots of opportunity for input, but this doesn't mean that you have to stop now. One of the goals of these town halls is to continue this dialogue, right? What's the evolution of thinking in the meantime? Are there more ideas that are coming up? Now, I will say the window is closing because by November 1st, the committee needs to have recommended to the project what we think the survey should look like. But do keep throwing your ideas at us because nothing's fixed yet. We're still running all the simulations and working out what fits. Okay. So in terms of that timeline, where are we at? So back in February, we finally got this committee up and going. We collected all the white papers and science pictures and reviewed them in March, April, June. We've done a few reports back to the community now. So there were several opportunities in July. There was last week. Now there's today in September. So right now, this is actually a really exciting time for the committee because we're all working through these really interesting problems. You know, if we decrease the cadence, what does this look like? If we increase the cadence, what does that look like? If we put more filters in, what does that cost us, right? Like we're now in the like nitty gritty costing of like, oh, if this costs 8 hours, you know, what does that mean for everything else? So for me, this is a really fun time. So that's where we're at the moment. We're literally in the kind of accounting for all of these things and working out what we can fit in. So we're hoping that by October we can, I'll show you our preliminary surveys today, but those are not set in stone. We're hoping by October we have more refined surveys. And then by November, as I said, we have to tell the project what we think they should do. So we just make a recommendation and then the ROTAC will actually take all of the recommendations from all the committees and allocate the time essentially. So we need to recommend the most science heavy survey we can that meets all the requirements. Okay, so let's talk about some of the modifications that have been suggested, the science cases, and kind of where the committee is standing right now. So one science case was to add a field at the Galactic Center. So as I showed before on this plot here, the Galactic Center is like right here. It's like super close to what would be the nominal fields that would maximize the microlensing yield anyway. And there's a lot of interesting stuff at the Galactic Center. There's, a lot of X-ray sources, so cataclysmic variables, X-ray binaries, a lot of interesting things towards the Galactic Center, compact object binaries, very cool stuff. And also, we could probe the whole stellar population and get kinematics on an area 7 times larger than any previous survey. This is the density of stars in the nucleus of the galaxy as a function of the distance. And so we've been able to do the nuclear stellar cluster like right in the middle of the center, but not the nuclear stellar disk, like this part out here. So if we added a field at the Galactic Center, we could really do a really interesting job of understanding the stellar kinematics near the center of the galaxy. So this one is not too far away from the other fields and has a really interesting science return. Even in terms of the microlensing survey, it's interesting to get a slightly different microlensing pointing to compare how exoplanet populations are changing as a function of like galactic distance, galactic latitude, right? Like having one slightly different pointing tells you a lot about how the planet populations are changing. So it even helps with the science case, which is cool. So this one at the moment is looking like it is a likely modification if we get the nominal or overguide. Oh, I should say we've been given 3 buckets of time: underguide, the minimum number of days, nominal, the middle number of days, and over guide, which would be the maximum number of days. So we have to design and recommend 3 surveys: under guide, nominal, over guide. So nominal and over guide currently both include a field at the Galactic Center. Under guide doesn't. Under guide is like stripped down. If we just had to stare at the at the microlensing fields and just get the requirements, that's what it would look like. Okay. Right, moving on. So we are likely to add a Galactic Center field. Okay, another thing, so as I mentioned, there is some pressure to move to a faster cadence. So the nominal survey, the Penny 19 survey, sorry, has a 15-minute cadence. So every 15 minutes you're returning to that field. And I'll clarify for folks, because it was news to me, this means like a 1-minute exposure on each field. Like given the slew and settle times, a 15-minute cadence is like a 1-minute exposure on each of these fields. So I was used to the like Kepler model where like 30-minute cadence meant you were integrating for 30 minutes. So you're only integrating for 1 minute, but you're getting it every 15 minutes. So here's a plot from Robbie Wilson's white paper showing as you go to shorter and shorter cadence, what your relative yield is in smaller and smaller planets. So, you know, for the very smallest planets, the Earth-like planets, you know, 50 to 75% increase if you can go down to smaller durations. And that's because the lower the mass planet, the shorter the duration of the microlensing event. You just need to be able to sample it better. You know, 3 points is better than 2 points for a half-hour event, for instance. And then this is also, you know, Rich just mentioned the free-floating planets. There's also support to going to a shorter cadence for free-floating planets because, again, they're just short-duration events. And the shorter the cadence you have, the better chance you have of sampling them and getting good parameters. Now, so this is what I was saying. There's this trade, right, with exposure, with cadence versus the number of fields. So we could add more fields at a slow cadence, or we could do fewer fields at a fast cadence. So then there are some variations we're considering right now, where, for instance, if you look at that, if you look at these like 7 fields, like maybe you just come back to this one twice every loop, right? So you're doing a loop, but you hit this one twice. So one of your fields is a double cadence, and the rest of them are just slightly less. Sorry, I overshot here. Or there's this idea of overlapping fields where here. So if you took these 2 fields and moved them down, you know, like this much, then, you know, this part would be sampled at twice the cadence. So that's another possibility, right? Like, how do we set up these fields so that we can increase the cadence without necessarily giving up fields, right? We don't want to give up fields because we need to be able to hit the number of microlensing events we need for our requirements. So this is the tension. Faster cadence also helps with astroseismology. Dan probably spent more time on this half of the slide last week, and I'm going to spend less time. The faster you sample the light curve, the better astroseismology you can get, which means the better stellar parameters you can get. Okay. So there were a few suggestions to add fields further away. So one group of suggestions basically centered around adding fields on nearby globular clusters. So this is the center of the galaxy here again. Here's those 7 nominal fields from the Penny paper. And here are a bunch of globular clusters. Now, globular clusters are really cool. If you have a bingo card, they're a laboratory for stellar formation, planet formation. Like, that's super interesting. The problem is, at the moment, the best globular clusters are just a bit too far away. I think we have a plot in here that I'll show in a minute that just shows we can't quite hit that 15-minute cadence on these fields if we have to spend too much time slewing out here. So we're still working on this. We're trying to see if there's a globular cluster or globular clusters that are, you know, maybe even closer or a better fit for the survey. So we haven't ruled this out, but just moving this far away actually kind of gets painful. On the right, this was a suggestion from Eamon Karen's white paper that we survey the Earth transit zone. So this is where planets could see Earth transiting in the galactic plane. So if you take this field, which is at L of 6 and B of 0, and put it over here, L of 6 and B of 0. So the Earth transit zone is here. Now, there are really interesting SETI arguments for why you would want to choose a point that other systems could see Earth transit, right? You know, having some kind of like mutual observability is a benefit for SETI. But this is too far away. It's really, really far away, just considering how long it takes to slew and that we need to keep at least, it looks like, a 15-minute cadence, if not less. So this one is probably unlikely. We're still trying to see if there's a globular cluster solution that works, but it's going to be a push. Okay. So in terms of the cadence in the fields and the exposure time, now you've heard like some of the science arguments in either direction. Yeah, so this is the slide I was talking about. So if you go from these 7 fields out to the Earth transit zone and back, the best you can do is a 16.6 minute cadence, which is rough. If you just add the galactic center, which is much closer, you can get below the 15 minutes. If you don't add any other fields, you can get below 15 minutes and stay and have 9 fields. So you can really throw in some more fields. And if you want to keep the 7 and go as fast as you can get down to less than 12-minute cadence. And this is for a fixed exposure time of 48 seconds. So this is just showing you like the kind of trades we're making. We can add this field and still stay below 15, but we really can't add this field and stay below 15. And so one of the, there was a lot of really good science that was proposed, and some of it is just better suited to that 25% general astrophysics program that I mentioned. Some of it is just too distinct from and doesn't fit neatly into the GBTDS. So it would be better if you just put in a proposal like, I want to go stare at this for 10 days and see what we see. So we really appreciate all the effort people put into the science, but some of it is going to have to be done under general astrophysics. It won't all fit in the GBTDS. Okay. Another modification that was suggested is off-season observations. So remember I said that there are 10 chances over the 5 years to observe the galactic bulge, right? There's a spring season and a fall season each year times 5 years. So that's what's shown on this axis here, 5 years, 2 seasons per year. Now, in order for us to achieve our microlensing survey goals, it's best to have fields right at the start of the 5 years and right at the end of the 5 years, because we want to maximize the proper motion between the source and the lens, so we can, get the lens flux and start breaking some of these microlensing degeneracies. So something might look like 3 seasons right at the start and 3 seasons right at the end if we get 6 seasons. What that means, though, is there's a 2-year gap in the middle where we don't look at the bulge. So some of the white papers were suggesting that we come back to the bulge in the off seasons and just get some low cadence observations. And the suggestions ranged from once a day, so just come back once a day and get some observation, to once every 10 days. And the sorts of science include, for instance, microlensing black holes. So black holes, much more massive. They have much longer microlensing events. They take hundreds of days. You wouldn't necessarily see them in a single season, but if you had low cadence sampling over a long time, you would see them. So, this factor of 100, they're 100 times longer than the free-floating planets, which are quite short, which is why you want to go to shorter cadence. So this is interesting because we might be able to fit this in. At the moment, we have this in our overguide plan. And we're currently working out, exactly what cadence, Jessica Liu, I think, is on the line, and folks are working out what cadence of the off-season observations would you need to get you what science. So we had a few different science papers, science pitches and white papers that suggested different cadences. So we're basically trying to work out what cadence could we get that gets us the best return. So for instance, the supernova survey, one of the other core community surveys, is doing a once every 5-day cadence. So maybe we could fit neatly in with that. Importantly, we also want to be good scientific citizens, right? Like if it takes an hour to get to our field and then we observe for 15 minutes and then it takes an hour to get back, that's 2 hours and 15 minutes for 15 minutes of observations. That's not a great use of Roman's time, right? So we also need to plan these off-season observations so that they're not onerously expensive. So once per day is probably looking like too much, even just in terms of how much it costs our total survey time. But like once per 3 days, we're looking at, once per 5 days, we're looking at, we might be able to fit this in. So that's interesting. Okay. Now, here are some cheap suggestions, which we think we can fit in just because they're so cheap. One suggestion was to observe each of the fields, whichever fields we end up with, in each of the Roman filters. So like either start the season or start the whole mission by sitting on these and just getting observations in all the filters. That helps us with all sorts of things, including stellar parameters, etc. And another one, this one I think gives people more heartburn, is to observe each field with the GRISM. Now, if you've ever done GRISM spectroscopy, the Roman field is very crowded, right? We're looking at the galactic bulge. We're looking at the densest possible region we can. and the GRISM is just going to smear all the light out on top of each other. But some preliminary analysis seems to indicate that if you did this, there's an incredibly large number of stars that you could still, reverse engineer and get really interesting and useful parameters for. And this would be cheap. This would be, up on the order of hours out of our hundreds of days. So that's another idea that we're looking at that's quite cheap. How often these ideas get done, like either once at the beginning of the survey, at the beginning and or end of each season, or with low cadence throughout the seasons, is still being worked on. But this is a cool and cheap idea. Okay, so this is the slide I think that changed from when Dan gave this talk last week. So Chris Pardo, who's on our committee, went off and thought a little bit more and did a little bit more analysis about this idea of detecting gravitational waves. So as gravitational waves come through, basically all the stars should shift together, especially on a small field of view like Roman. All the stars should just shift together. It's tiny, but it happens. And so Chris's original white paper was that, if we had very high cadence observations, like 1 minute cadence, like very high, like one field at 1 minute, we might be able to detect this. Unfortunately, it turns out that the fine guidance sensors, their entire job is to make sure that if all the stars move in one direction, they get moved back again. So this is probably not going to work with the reaction wheels turned on. And I don't even want to suggest to the project office that we turn the reaction wheels off for any part of the Galactic Bulge time domain survey. So this turns out is probably unlikely to happen. We'll keep the reaction wheels on and we'll let the fine guidance sensor make these corrections. But it was a really cool idea, and I'm glad Chris went off and thought about it and did this math. So we're probably unlikely to do this like one field at very high cadence thing, but it was a fun idea. Okay, we also got a number of white papers that were, sorry, time check, 10:30, doing fine. We also got a number of white papers about Roman synergies with other projects. So there was Roman and Euclid synergies and Roman and Rubin synergies. So these were really interesting and really valuable papers to read. At the moment, they're not impacting the choice of survey. We're not choosing our fields based on these or choosing our cadence based on these. We're choosing an independent, maximally good for Roman set of parameters for the survey. And we're, hoping that ends up working out well with Euclid and Rubin. It just, once you get into the politics of it all, it got very difficult to actually try and in advance promise that X, Y, Z would happen. So we're not letting the synergies impact the survey design at the moment, but we're open to working with the other projects to maximize the science that comes out. Okay. Now we're getting into the real guts of things, folks. This is about how we read out the CCD. So if you read out the CCD in even chunks in terms of time, that would look like this top one, R1, R2, R3, R4, R5. And you would not do a very good job of detecting flares. And importantly, you would saturate quickly on saturated stars, right? If you're reading out this equal chunks at a time. If, however, you do uneven resultants, if you read out a short bit and then a slightly longer bit and then a slightly longer bit, you won't saturate as quickly on stars, and you'll be able to do interesting science where you're like sampling flares. So this is kind of with even resultants, it squishes it out, but with uneven resultants, you sample this much better. So this, I think, this was a white paper that was submitted to do cool flare science. I think this person is going to get this for free because of the way we're doing the readouts for saturated stars anyway. So that's good. But yes, this is very, very in the details now. How are we reading out the CCD? But this is the level of detail we need to go to make sure we do the best science. Okay, so here are the three surveys that I mentioned before. We've been given an underguide, a nominal, and an overguide. You can see the relative numbers of days, 380, 420, 440. And so here are preliminaries just across this, because this is just basically taking the most basic ideas we have and seeing if they fit. The underguide, the focus would just be, can we meet the microlensing survey requirements with the underguide? And we expect we can, but we need to do the simulations. So this is 6 63-day seasons with just the contiguous fields. So that's the 7 or 8 or 9, whatever we end up just there. No galactic center, no off-season cadence observations, just the seasons on those fields. And because it's so cheap, taking one image in all of the filters of all the microlensing fields. The nominal version lengthens those seasons to 70 days instead of 63 days and includes a galactic center field. So we bounce up to the galactic center once per rotation. It includes taking one image of all the microlensing and all the filters because it's so cheap, and it includes a GRISM spectrum image of all the microlensing fields because it's so cheap. Now, 440 days is where we start to get the deluxe Cadillac version of this. So this is the maximum season lengths of 72 days. We can't go longer than that. It's one image in all filters. It's one spectrum in all the fields. This is 4 off seasons. So remember, there's 10 seasons in total. 6 will be at high cadence. So the 4 off seasons would be 1 observations at once per day. This is, again, the most expensive version. And then this last one, which we will probably cut out now, the 1-day high cadence observations of 1 field each season. So this one will probably go, given the most recent work that we talked about with Chris yesterday. So currently, Matt Penny and his illustrious crew are off simulating all of these and trying to work out, what do we need to do to meet the microlensing survey requirements. So we're excited about these. We'll have actual simulation results. I'm going to hold Matt's feet to the fire. He said 2 weeks from now we'll have more, so that's good. So we're moving ahead with these. And we're really excited by this survey, right? Regardless of exactly how it ends up, you guys did an amazing job of thinking of all of the cool things you could do if you had high precision, high cadence photometry on the Galactic Bulge. It's very cool. Variable stars, stellar physics, compact objects, stellar kinematics in the galactic center. There's a lot of really, really cool stuff that you guys are going to do. So there is a questionnaire here. There's a QR code and a link. These slides are available. This link is probably the same one that Ari put in the chat and can put in again. Or you can email us directly. Thank you. After Dan's talk last week, we did get some really useful, helpful emails. So, if you think the barrier is too high, it is not. Email us your thoughts. So that's me. And then Dan is here twice. He is only one person, although the amount of work he does, I'm not surprised. He's got 2 email addresses. He's at both Hawaii and Sydney. So you can email us. Please go and fill out the questionnaire. And that's the end of my slides. Thank you.
All right, let's thank Jessie for that awesome talk. Yeah, I'll give her some clapping hands emojis. You can click the little smiley face icon and get some clapping hands. And now we'll take questions. Before we do, though, just a friendly reminder to please fill out the survey in the chat that Ori posted, as well as clicking on the outer space link to join the Roman community as well. Now we'll take time for questions. You can ask them in 1 of 2 ways. You can raise your hand, as Dave has already, or you can write your question in the chat, as Dick has already, and I'll read your question out loud. So I think I saw David's hand go up, so go ahead and ask your question, David.
Hi, Dave.
So, so you mentioned a couple times that you get a maximum of 72 days, but as far as I know, the hardware may allow more than that in the early seasons, because the limit is based on getting sufficient power for the solar arrays, but that decays with time. So early, the first few seasons, you can probably get more power at looking further away from the optimum.
Okay, my understanding from the project office when I pushed them pretty hard on this is that we should not go more than 72 days, because I was like, wait, why? Tell me exactly why we can't go more than 72. And they were pretty
well, I think so they want to have the freedom to move things around that might give some problems, but so it may be that wouldn't be finalized till after launch. But I was wondering if if that's something that you could recommend that we check out, whether that's an option. And then my other question was with the galactic center field. As I mentioned before, it seems like measuring the masses of exoplanets found looking toward the galactic center will be more challenging than other fields. And actually, Jay Anderson's analysis of some JWST data gave another reason why it's more difficult. It's harder to build PSFs when you have a much wider variety of colors that you get in the galactic center field. But in terms of trying to verify that we can meet our mass measurements, the mass measurement requirement is a percentage of of planets found. And if we have a lot of planets found toward the galactic center, it might be harder to meet that percentage. I think we discussed this before, but I was wondering if you had some guidelines on how to do the mass measurement requirements. Should we ignore the planets found in the galactic center?
So my understanding from, yes, so we talked about, for folks online, we had a version of this discussion at the Roman conference in Pasadena. Talking to the project office people after, they seemed fine with the idea of adding a galactic center field, getting bonus planets there, but them not being part of the like microlensing survey requirements. That the microlensing survey requirements can be done with the contiguous fields, and then if we add a galactic center, cool, bananas, great if you find things there, but that you wouldn't be penalized for not being able to get those. And I assume for the statistics, right, like thinking of building this up as a statistical survey, the idea is to do two different sets of statistics because this is a different pointing with a potentially different population. So you wouldn't lump them all in together anyway and try and do one big analysis. You would do an analysis on the contiguous fields, and then you would see, like, does this population of events look different? Now, if we don't have mass measurements for as many of the galactic center events, I'm curious, Dave, whether you think that hinders our ability to do more broad population statistics if we don't have individual masses.
Well, I mean, you know, if we're getting an extra set of data that, I mean, I don't really think that, you know, hinders the results. You know, a lot of the, well, I mean, we're looking at, you know, long lines of sight through the galaxy. So, so you do get information, you know, from the nominal fields, you know, the distribution.
Sure. There's
there.
some galactocentric population distribution, hopefully.
Yeah. So, and well, well, so a lot of the problems with the galactic center fields are, you know, that we have to show that you know, we can meet the mass measurement requirements now. Oftentimes, it's much easier to show it when you actually have real data, what that looks like, and you have a chance to like develop your software based on that data. So, I mean, you know, if we're not counting out toward the mass measurement requirements, then you know, there's a little bit of a hit just from, you know, doing the galactic center field rather than one that's a little bit more optimized for getting mass measurements. But
I mean, that's exactly the trade we need to do, right? Like, can we have that field and still meet the requirements, or does that field need to be in a contiguous set so that we can, you know, have a faster cadence, have more fields with a higher yield versus this field? That's, I mean, we're doing that trade. We're not going to do the galactic center if we can't meet the requirements when we include it.
Yeah. Are you considering a different cadence in the galactic center?
Oh, that's a good question. It kind of you have to kind of bounce out for it. So I don't know if Matt is on. Yeah, how to see everybody.
I don't think I saw him.
I will ask Matt. I think at the moment he's just considering the one scenario where you try and fit that in and have it less than that.
Should be.
Yeah. I'd have to think about, I'd have to remind myself of exactly the specifics of the galactic center science and what cadence it needed. I don't remember off the top of my head.
Okay.
Okay, thanks, Dave.
Great. Next, we have a question from Dick. Before I read that out loud really quickly, this talk has been recorded, and all the other previous talks and all the talks of this series will be recorded and posted on the Roman Community Forum website. I just put the link to that into the chat, and I also just put the links to the feedback form, as well as the link to our outer space page to sign up for the Roman community today as well. So getting to Dick's question. Dick asks, has anyone analyzed how robust the science goals are against occasional spacecraft anomalies? For example, spacecraft's escaping events, etc. My sense is that the impact would be minimal, but I wonder if this is something the team needs to worry about.
Yeah, no, that is a good question, and it is something we've talked about. So it has the basic effect of decreasing the length of your season, right? So because it's a statistical survey that we're doing over many, many events, you know, if we lose a few days to a safe mode, it's basically just like you made the season a few days shorter. So that is part of what Matt is and his crew are simulating right now. You know, it seems like it's a fairly smooth function of the season duration, you know, what the yield will be, and we're getting the exact nature of that function. So we'll be able to, in the recommendation report to the ROTAC, we'll be able to say we can tolerate losing this much, but no more. We also need to provide them that because there are things like targets of opportunity, right? Like the ability to go and look at something else and come back if something else interesting is happening over here. So we need to be able to say, you can have some of those, but if you do more than 10 days of that, then we'll start to not be able to meet our requirements. So that is definitely one of the things that we're putting in the report. Thank you, Dick.
All right, and Dave, do you have another question or just a residual hand? Looks like residual hand. All right, any more questions for Jessie at all? Oh, Richard, go ahead.
Just one quick question. One of the slides mentioned how the coordination with Euclid was being considered, and I wondered, was there any white papers that discussed possible coordination with Earth 2.0?
Earth 2.0.
That's the Chinese rig.
Yeah, I know what it is. I'm just trying to remember. I don't think that came up in our discussion, so I'm going to assume not.
Okay.
Yeah.
Puzzling. Anyway, I'm personally very excited about free floating planets, and I don't know, to say we're going to complete a census of the planets in the galaxy with only getting a frequency measurement on those. It's not really a census, but I would argue. Anyway.
Mm-hmm.
Thank you, Jessie.
No worries. Thanks, Rich. Any other questions, folks? Again, email me. I'll put my email in the chat because it's off the slide. And I'll put, that's my email. And then let me get to Dan's emails really fast. Multiple emails. Email us if you have questions or want to provide input or, you know, have thoughts. We're very open to thoughts. We like thoughts.
Not seeing any hands, not seeing any questions in the chat. But again, if you do have any outstanding questions or comments / feedback, please do get in touch with both Jessie and Dan. And also a reminder again that our next one of these is tomorrow morning at 7 a.m. Pacific, 10 a.m. Eastern. So it's the high latitude, wide angle or wide area surveys as well. And this talk will be posted on the Roman Community Forum website as well.
All right. Thanks, Rob. Thanks, everyone.
Yeah. All right. Thanks, everyone, for calling in. Really appreciate it. And talk to you all next time. Have a good one.
Bye.